Hi, this is Tom, and this is Lesson 25, the Central Limit Theorem. Here we go. We're going to, begin with this. Consider the data set. Consider the set of data 2, 4, 6, and 8. We're going to first make a histogram of this. So here we go. Let's go, here's 1, 2, 3, 4, 5, 6, 7, 8. I even go to 9. I'm going to label all of these. And since our data is even numbers, notice that my boundaries between 2 and 4 would have to be right in between that, so that would be 3. So and they each occur just one time. So let's over here, this is our data, x for data, and we'll put our frequency on the horizontal axis just like we've done before. So 1, 2, 3, 4. But in this case, all we need is to go to 1. And so when I start graphing these, we'll use a different color. Then my first one, my 2's, would have this big, broad histogram bar like that. And as a matter of fact, the 4's, they also only go to 1, or the 4, the 6, and finally, they're kind of getting shorter there, the 8 would look like that. Now, let's find, like most sets, and we've just learned about variance, so now we're going to find both the mean and the variance of the data. And for this case, let the mean be mu. So, well, if the mean is mu and standard deviation and variance, we'll use sigma for standard deviation and sigma squared for the variance. Okay, so I think we're ready to begin. So the mean means I take my data values of my 2 plus my 4 plus 6 plus 8, and we divide it by the number of data, that's 4. And if I add those up, that's going to give me a 20. We'll divide it by 4, and my mean is 5. And then let's find the variance. So the variance says we're going to take the data, which the first one is 2, and we'll subtract the mean and square that, plus the next data value is 4 minus the mean of 5 squared, plus our next data value is the 6 minus an 8 squared, plus, and then our, oops, I'm sorry, not an 8. Oh goodness, you shouldn't let me do that. My next data value is 6 minus 5, and then finally my last one is 8 minus 5 squared. We're going to take all of that, and then divide it by the number of data. So we're getting the average of the square of the distances. So let's see, if we work through this, 2 minus 5 is negative 3. We square it to get a 9, plus 4 minus 5 is negative 1. We square it to get a 1, plus 6 minus 5 is 1. We square it, 1, plus 8 minus 5 is 3. Square it, that's 9. Divided by 4. Oh, look at that. 20 divided by 4. So, wow, our variance is also 5. And remember then that the standard deviation says you take the square root of your variance. So in this case, we take the square root of 5, and that's our answer. Since 5 is not a perfect square, we can't simplify it anymore. We're going to leave it as the square root of 5, which is what we would call the exact answer. And you'll see why we're leaving it that way at the end of the lesson. All right, now here's what we're going to do. What we are going to do next is take all possible samples of size 2. So let me write that down because that's kind of a crazy concept. We're going to take all possible samples of size 2. And we'll put, just for clarity, that repeats are allowed. Okay. Then find the mean of each sample. Find the mean. We're going to call that x bar because it's going to be the mean of a sample, so we'll find the mean x bar of each sample. Wow, all right. So we're going to kind of direct this so that it works out best. For example, let's see, I could take a sample. We'll keep a track this way. Sample and the mean. We'll probably have 2 columns because I think there's going to be quite a few of these. And then sample, mean, and mean x bar. So, for example, remember my data set is just 2, 4, 6, and 8. So I'm going to be very systematic. I could have a sample of maybe a 2 and then a 2. Then I could have a sample of a 2 and a 4. I could have a sample of a 2 and a 6, 2 and an 8. And those are all my samples that have the 2 coming first. So now let's go to our 4s. I could have a 4 and then a 2. I could have a 4 and then a 4. A 4 and then a 6. Or I could have a 4 and then an 8. Well, let's keep going. Now let's start with the 6s. I could have a sample of 6 and then a 2, a 6 and then a 4. Then we could have a 6, a 6, a 6 and an 8. And finally we're down to our 8, so I could have 8, 2. I could have 8, 4, and 8, 6. And my last one is 8, 8. And those would be all of my samples that I could have. Now, let's take the mean of each sample, which means you'll add the 2 data and then divide by 2 since they have 2 values. So the first one, we'll write it out. This is going to be 2 plus 2 divided by 2. So that's 4 divided by 2, so I'd have 2. Let's make that a little bit cleaner. And so my mean x bar is 2. And then if we continue this process, I'll write a few more of these. The 2 plus the 4 divided by 2, that's 6 divided by 2 for 3. Then if we take 2 plus 6, divide that by 2 to get 8 divided by 2, that's 4. And then 2 plus an 8 divided by 2, that's going to be 5. And so I would encourage you to pause the video for a moment and continue making this chart. Fill it out yourself, and then we're going to go forward from there in a moment. So I'm going to pause the video, and I think you should do the same. When you get back, we'll continue with there. And all right, we're back. So let's see, I have my next one then became a 3, 4, 5, a 6. My next one became a 4, a 5, 6, a 7, and then my next one became a 5, 6, a 7, and an 8. Now, here's what we're going to do with this next. A few things. The first thing is let's find, now what we're going to do is we're going to find the mean of the sample means. The mean of the sample means. All right, here we go. So now, this is kind of a strange idea, but these are our sample means. All of these little values here, we've got 16 of those. Those are the samples, or the sample means. We want to find the mean of those. And we're going to call the mean of the sample means, we're going to use this symbol mu with an x bar as the subscript. That means the mean of the sample means. And here we go. So my mu x bar is going to be the 2, 3, 4, 5, oops, 2, 3, 4, 5, 3, 4, 5, 6 plus 4, 5, 6, 7 plus 5, 6, 7, and finally 8. I'm going to add all of those together, and notice there's 16 of them, so I'm going to divide all that by 16. And I'm going to try to add these up. If we go from the outsides here, there's an 8 and a 2 is a 10. 7 and 3 is 20. There's a 20 plus another 10, that's 30. 5 and 5, that's 40. 7 and 3, that's 50. 60. 70. 80. So it looks like this is 80 divided by 16, which is 5. But wait a minute. Notice that that is exactly the same mean as we found up above and when we just called it the mean of the population. Remember the 2, 4, 6, and 8. Wow. All right, we're going to stop at this point, and in the next video, we're going to make a frequency distribution and use that to find the standard deviation of our sample means. We'll see you in the next video. Thanks for watching.